So the next topic we'll dig into for AP discovery is the DNS Resolution Method. So one, this requires an AP to be able to reach out to a DNS server. So in order to do that, it needs to know, at a minimum, a DNS server IP address, and ideally it also has a domain name associated with it. So it can learn that most easily through DHCP. The DHCP scope can provide that information to the access point. You can also use this with a statically IP'd access point. The trick with that one is you can't actually configure the DNS information from the console of the AP. You have to do it after the AP is actually associated up to a wireless LAN controller. So you can run into a little bit of a chicken and egg scenario if you need to start with a static IP and you need to rely on this method. You have no way to do that. Now, one trick that you can actually use with this is, just like we did the IP helper trick with the CAPWAP 5246 traffic, you can use an IP helper trick with the DNS packet, because the APs actually will, if they don't learn about a server, will broadcast a DNS lookup to an all255's address, and since it's UDP, we can use the IP forward protocol command and specify UDP 53 for the DNS port and say any broadcasted DNS traffic, send it to the DNS server. Again, this would just be a temporary thing to get it up and running, otherwise you're going to get lots of broadcast junk going to your DNS server. You may want it, you may not, but that is one last method to get it to work in case you do have to start off with a static IP, but you have to use the DNS resolution method for one reason or another. Now, once the AP actually reaches out to the DNS server needs to be able to respond with an IP. So you need a forward lookup entry, or you might see it referred to as an A record, which is just an IP4 lookup entry so that it resolves Cisco-CAPWAP-controller to the IP address of the management IP of the controller you want to discover. This is actually really easy to verify on the AP itself to know if this method is actually working. First method you can do is just go to the console of the AP and type ping Cisco-CAPWAP-controller. If it responds, you should see it if it resolves to an IP address, and if you can actually ping the IP address, that lets you know it's working. The other way that you can do it is by looking in the AP logs. So you can look in the AP logs for this translating Cisco-CAPWAP-controller line. The IP address is going to be the IP address of the DNS server, so you know if it's using the correct DNS server right there. And if it actually says OK at the end, that means that it was successfully able to resolve the host name to an IP address. So either method, either the ping method or by looking in the logs, you can quickly verify whether DNS resolutions are working. So let's go ahead and show you how to configure that on our devices. So what we'll do on this one, we have APs in both in VLAN 114, or we have a single AP, I should say, in VLAN 114. We'll try to get that to discover a controller using DNS resolution. Now, we have a couple possibilities in terms of configuring DNS. You can configure it on your corporate DNS servers, so whatever you have, configure a record for that. Alternately, we could use, actually, routers can be DNS servers, and maybe like a lab. So if you had a router as opposed to a switch, the switch code doesn't have the commands for it. But a router can actually configure itself to be a DNS server, return the host lookup responses, and get you working there. But for us, though, I'll show you how to do it on a Windows server. So let me go ahead and jump on that, and we'll show you how to do that. So in the Windows server, you would want to get to the DNS entry. Let me go ahead and close these out and show you from scratch how to get there. If this would actually close. Windows, isn't it lovely? There we go. Okay, so you would find it under Administrative Tools, go to DNS, look for your forward lookup zones. Underneath there you'll have one or more actual zones. Find the zone that you want to resolve with. So in my case I'll do proctorlabs.com. Right click on it, choose new host A, this is our A record. You would type Cisco-CAPWAP-controller. It'll automatically put the proctorlabs.com at the end of it because we're in the proctorlabs.com forward lookup zone. And then you would type in the IP address of the controller you want to discover. We'll do 112.10, so this is my wireless LAN controller 2. You would click on Add Host. You don't need to worry about a pointer record. This is a reverse lookup, so you could resolve a host name from an IP address. We don't care about that for this discovery method. You would hit Add Host. It would tell you that it added it. Now I already did it before, so we see that I have an entry for Cisco Cap Web Controller to 10.10.112.10. Now if I want, I could actually add in multiple entries of Cisco-Cap Web-Controller to different IP addresses. And the way that this would work on a Windows server is that it would round robin the responses. So the first time it gets a response, it would return IP address A. The second time it gets a response, it would return IP address B. So we can teach APs more than one IP address over the whole, but only one at a time. We'll just leave it with the one entry though. Now I'll go back to my switch. So VLAN 114 lives on Cat 2. Here, all I need to do is configure a DHCP scope and make sure that my APs are learning about the DNS server. So let's go ahead and do that. IP DHCP server VLAN 114. Oh, sorry, pool. IP DHCP pool. I have to give it a network. 10.10.114.0. It's just a /24 network. Give it a default router, 10.10.114.1. And now we'll define a DNS server. This is the IP address of my server. And then a domain name, proctorlabs.com. This should be everything that my AP needs in order to reach out to the DNS server, resolve it. So let's go ahead and take a look. Okay, so we see that my AP actually grabbed an IP address already. Now, the second I enter that network command, the DHCP's pool goes live, and unfortunately, I didn't get the DNS commands in there before it actually tried to resolve. But normally what we would expect, and once it goes through the process again, it'll use the actual DNS server. But we want to look for this translating Cisco-Cap Web-Controller line. We want to see it using the IP address of the server that we're giving it, and then we want to look for that OK at the end. Now you notice that this AP is actually looking up both Cisco Cap Web-Controller and Cisco LWeb-Controller. And the reason for that is that this AP is a little bit older. It's a 1242. So I've noticed on some of the older APs, I don't know if it's due to the recovery image or what it is, but they actually, if they came from old code, they seem to try to resolve both. But any newer APs, for instance, a lot of the 802.11n APs, they only ever try to resolve Cisco-Cap Web-Controller. So always just plan on Cisco-Cap Web-Controller, never assume that LWeb-Controller is going to work. Okay, so now I see what I want. It started over, this time it got the extra information from DHCP. And now I have this entry here. So I get the domain server of 10.10.2.10.6, and it says OK at the end. It was able to resolve that. Now we see it actually joined up. If I want to, if I didn't catch the logs and I actually want to just test it, ping Cisco-Cap Web-Controller. I see it resolves to 10.10.112.10. That's my controller's IP address. I have connectivity, great. That's the way I would validate it, either with the ping method here, or, through the logs, looking for this specifically with the OK at the end. And that's a really easy way to validate that DNS resolution is working for your APs.